Hi everyone, so now we're going to be talking about how to use triangle trigonometry to solve word problems. It's really similar to the last two videos, except for now instead of giving you a triangle, the questions are asking you to draw the triangle based on the word problem. So before we get started with the examples, I wanted to go through two different vocabulary words that you're going to be seeing in these questions. The first one is called angle of elevation. So angle of elevation. And the other one is called angle of depression. So in a triangle, in a right triangle specifically, we have the right angle, but then we also have two other angles. Now, when it's asking you to find or use the angle of elevation, it's talking about the angle that's closest to the ground. On a lot of word problems, on these word problems, we're going to be drawing right triangles for every single one of them, and we're going to be using the ground as a portion of the triangle or the bottom of the triangle. And so when it's talking about the angle of elevation, it's talking about the angle that's not the right angle, but the other angle that's closest to the ground. The angle of depression is the other one. So it's the angle that's on the top of the triangle that's furthest away from the ground. It's almost backwards in my brain. Like I would think the angle of elevation is above and the angle of depression is below, but this is the way that we need to learn it because this is the way that the rest of the math goes. So let's get started with the examples. I didn't write out word for word the examples, but instead I'm just going to read them. You have the examples in front of you, so you should be able to read them as well, and then I'll write down the important bits. So example 1 says, Matt is standing on the top of a cliff above a lake. There is a boat 230 feet away. So I'm going to say boat 230 feet from the base of the cliff, and the measurement of the angle of depression is 42 degrees. How tall is the cliff? How tall is the cliff? So we were given some information, but we're going to say, okay, here's my little boat, right? And we know that Matt is standing on the top of the cliff away from the boat. So here's Matt. And look at that. We kind of already made a right triangle if you can see it. So there we go. There's your right triangle. We know the boat is 230 feet away from the base, so this is 230. And we know the angle of depression, which we just talked about as the top angle, is 42. So this angle right here is 42 degrees. And then this is our right angle. We want to know how tall the cliff is. So this is my X or my question mark. That is the hardest part about all of these examples, is being able to draw the triangle. So I'm going to redraw the triangle just so we don't have all of the funny pictures on it. So this is my X side. We know this is 42 degrees. This is 230. And look at that. Now we're just solving for a side, which is what we were doing in the last video. So the first thing I'm going to do is label my sides opposite, hypotenuse, and adjacent. Opposite, hypotenuse, and adjacent. And then we have our opposite. We want our adjacent. So I'm going to use tangent. So tangent theta is equal to opposite over adjacent. I didn't write these down on this video, but you do have a cheat sheet with all of these on there, the trig ratios. We're going to plug in what we know. So tangent 42 is equal to my opposite side, which is 230, over adjacent, which is x. Because the x is on the bottom, we're going to flip-flop the tangent and the x, which would give us x is equal to 230 over tangent of 42. And now I can plug that into a calculator, 230 divided by tangent 42, and I end up with the x is equal to 255.44, which means that, and that's in feet. This is a word problem, so we need to make sure that we use our words to represent the numbers. So the cliff is 255.44 feet tall. All right, let's go through another example. This example says, from a 200-foot observation tower on the beach, a man sights a whale. The angle of elevation, so let's see, we have 200-foot tower. So this guy sees a whale. the angle of elevation is 7 degrees. And how far is the whale from the shoreline? So where is the whale? All right, let's draw a picture. So we've got a guy on a tower. There you go. And we know that it's the beach and there's the whale. Not an artist, guys, at all. There's your whale. So if you can see, we've already got our triangle. If I just draw a line down to the whale, we know the angle of elevation is 7 degrees. So this part is 7 degrees, and we know this is our right angle. And we want to know, oh, and the tower is 200 feet tall. We want to know how far the whale is away. So that's my x. All right, so cool. That's our triangle. I'm just going to redraw it without my goofy pictures. My right angle, 7 degrees, 200 feet right there, and there's our x. First step is to label our sides opposite, hypotenuse, and adjacent. So here's our opposite, here's our hypotenuse, here's our adjacent. We have our opposite, we want our adjacent, which means we're going to use the trig function tangent. So tangent theta is opposite over adjacent. Let's plug in what we know. So we'd say tangent of 7 degrees is equal to my opposite side, which is 200, over adjacent, which is x. And then once again, we're just going to flip-flop these two so that we can get x by itself. So x is equal to tangent, so let's see, sorry, 200 over tangent of 7. Now let's plug that into a calculator. We're going to say 200 divided by tangent, 7 degrees, and that gives me the x is equal to 1628.87 feet. So the whale is about 1,629-ish feet away from the shore. All right, let's do another example. This example, so number 3, the third example says a 10-foot ladder leans up against a wall. Okay, I'm just going to draw this. So here's our wall, here's our board, and here's the ladder. We know the ladder is 10 feet. The distance between the bottom of the ladder and the wall is 3.4 feet. And what is the angle between the top of the ladder and the wall? So this is like my theta. That was a little bit easier for me to draw than to write out, but hopefully that made sense the way that I wrote it out. Because the wall is standing somewhere on the ground, this would be like, this is our wall, and this is the ground, and then the dotted line is the ladder, right? So redrawing it just so we have just the triangle. This is our theta, 10 and 3.4. First step is to label our sides opposite, hypotenuse, and adjacent. And then we have opposite and hypotenuse, which means we're going to use the trig function sine. So sine theta is opposite over hypotenuse. Let's plug in what we know. So we'd say sine of theta is equal to 3.4 over 10. To get the theta by itself, we have to do the inverse sine. So we'd say theta is equal to the sine inverse, or sine to the power of -1 of 3.4 over 10. And now that's something that we can plug into a calculator. So sine inverse of 3.4 over 10. And I get 19 theta is equal to 19.88 degrees. All right. And that one, as long as you have the degree symbol on there, is correct. It doesn't need another word because it's just in degrees. All right, let's go through the last example. So example number 4 says you are standing 46 feet away from a 500-foot skyscraper. Here's my skyscraper. Yay. And here's you. So you're 46 feet away from it, and this sucker's 500 feet tall. What is the angle of elevation between you and the top of the skyscraper? So if this is my triangle, the angle of elevation is on the ground, so this is my theta. All right, so let's redraw. 46 theta, there's our right angle, 500. We want to solve for theta, so first step is to label our sides opposite, hypotenuse, and adjacent. Then we have opposite and adjacent, so we're going to use tangent for our equation. So tangent theta is equal to opposite over adjacent. Let's plug in what we know. So we'd say tangent of theta, theta is what I'm solving for, is equal to opposite side, which is 500, over my adjacent side, which is 46. If I want to solve for theta, I've got to get rid of the tangent by doing the inverse tangent. So theta is equal to tangent inverse, or tangent to the power of -1 of 500 over 46. And that is something that we can plug into a calculator. So tangent inverse of 500 divided by 46 gives me 84.74. So theta is equal to 84.74 degrees. All right, so as you can see, these are just like what we've done in the last couple of videos, but you need to be able to draw the picture of the triangle first. So that's how we solve word problems with right triangle trigonometry.